small use case and what limitation that has got transformed out, so that we will try to understand. Okay, so yeah. So let me start. Yeah, so any question you can put it on chat box. Okay, I will be getting through the chat box periodically. And yeah, so let's start with the fundamental. So guys, most of you have known about this ChatGPT. How many of you are very new to AI? How many of you are very new to AI? You can raise your hands. How many of you are very new to AI? Okay. Okay. How many of you very new to AI? Okay. Cool. So natural language processing, before eventually coming to ChatGPT, okay, I will focus on natural language processing, NLP. Okay. So NLP is basically an area where you go and basically handle unstructured data. Okay. Unstructured, it's like data is of multiple structure. Okay, you have a semi-structure, quasi-structure, unstructured. Okay, and there are different type of dimensions that you have in the data. So one such is basically unstructured data. For those who are very new for them, now I will give some basic definition of unstructured data. So typically unstructured data is somewhere your tweets. Okay, this is an unstructured data. Facebook comments, this is an unstructured data. Something which is not in form of rows and columns. So that is what is your unstructured data. Okay, so something which is in row and column, that you can take it as a structure, which you can represent it. Okay, and something which you cannot represent it in form of rows and columns, you take that particular set of data as a structure, unstructured data. So tweets are unstructured data. Okay, different comments that you get in Facebook, okay, those are unstructured data. Then eventually your image is also an unstructured data. Okay, because you cannot put your image in rows and columns, though you can bisect your image into rows and columns, which eventually I will take it up later. But eventually it is not a single value or a single number that you basically get stored. Now, what is an example of structured data, guys? Something like your bank information. Okay, that is very structured. Okay, how much amount is getting credited, how much amount it is getting debited, right? How much EMI is coming in. So all of those information that you can represent in form of rows and columns. Okay, that you can take it as a structured information. Okay, in which date the money got debited, in which date the money is getting credited. All those informations are part of your structured data. Now, eventually, as we are growing, our business is also expanding. Okay, so now previously there were no such influences were there with social media. Okay, most of the businesses were very transactional. Okay, you need some items, you go to the store, you get the product, and that's how you meet demand and supply, right? You don't need to give any advertisement technically in a social media, because presence was not there, influence was not there, right? Now that dynamics are changing over a period of time, and lot of demands that are getting generated through social media. A lot of business, they don't have any physical existence. Okay, they all are completely running with the help of social media. Okay, so one such beautiful example I will take it up, that is you can say Redmi. Okay, while Redmi launched their mobile phones, they were not very much focused with their physical stores. Okay, they have launched the store. They while their product were well known. Okay. Post that, they have started launching the store. If you get through this understanding of how these brands were basically built, okay, they don't have any physical existence, right? So entire marketing that they have done is completely digital in nature. Okay. And they try to take those investments which were specifically in terms of physical investments. People buy stores or they rent out the store. They invest heavily on the infrastructure. Rather than that, they focused their investments in building a very smart, cheapest product. They did a lot of investment on social media platform. They understood that, yeah, social media can easily reach out to every parts of the world. And that's what significantly basically helped them to grow their brand out of the box. And that's where the slowly the transaction came in, and Redmi became one of the largest mobile seller in India and in many other countries as well. They are now getting a lot of impression out there. They do have multiple parent brands, I mean sister brands, sorry. um, Oppo, Vivo, they all are the sister brands. Okay. And they all operate, just to give you a different feeling of different brands. Okay. But they all are aggregated to a same parent brand. Okay. So this is also one of the marketing strategy and one of the marketing sense that comes out. So coming back to the point that digitalization has heavily enabled this unstructured data. Okay. So far it was very transactional. Data was very transactional. Now it is a lot of unstructured data comes in place. And the next step was we need to really store these information. Okay. We need to store this unstructured data. Okay. We need to store the unstructured data and make use of this unstructured data for our future analytics. Okay. So very simple, like if any organizations want to do a campaign or eventually they want to launch a product. Okay. So what they need to do, they just need to get a kind of a feedback. Okay. From the entire community. Okay. And eventually they will understand, okay, this product is worthy or not. If this product is not worthy, then how can you mitigate that? So all those information you will eventually get. A lot of market research has become very easy because you can now pull the data digitally, right? So we store these unstructured data in form of big data environments. Nowadays we have clouds. Previous to this evolution happened, cloud was also not so much efficient, and it was in a very building phase. Okay. It doesn't have a lot of connector with different application. It was not having a lot of APIs that are now available. Okay. And a lot of other tools, associated tools along with the cloud services also got emerged. And because of that, storing the data has also become very easy. Storing, once cloud came into the picture, storing the data on cloud is much cheaper comparative to the data centers, which were very expensive. So overall, the experience that we get it with this set of technologies and tools, that you take any given data, store it into your cloud environments, and then pull it out, or store it into warehouse or anywhere. Okay. And then pull it out and put it into an analytics engine. Okay. Where you go and perform any type of research, or what is your overall business objective that you try to perform out there, and then get your required set of results. So that is what is the overall analytics framework that comes in. Okay. You take the data, collect it from different sources: Twitter, LinkedIn, Facebook, YouTube. Okay. And all the Google search, from everywhere, collect it from everywhere, and then typically get the data, store it somewhere in the warehouse, and then start doing the analysis, and then probably get the results. So that is typically how the overall platform works. Okay. So one of the most interesting fact is, during this evolution was happening, evolution towards these algorithms were also happening. Now, coming to specifically, we will not focus on entire machine learning or entire AI. We'll be very focused to ChatGPT, how the foundations are. Okay. Eventually, I can show you one small example today. Okay. And what are the things previously you used to build it out, and now what are the transformation happened? So I will focus on those things in a more broader spectrum. Okay. So the first one is basically we'll discuss about in terms of natural language processing. One was the one game changer was basically your chatbots or conversational AI platforms. Okay, so you might have seen for every given platform, maybe in Amazon or maybe in um, eventually in banking system, in Zomato, Swiggy, all the food delivery apps, even in Uber. Okay, you get a chatbot or conversational AI platform, right? Now this makes the life of support team much easier. Okay, why? Because whatever questions you have, okay, can be easily answered with the help of this chatbot. So let's say previously, just try to remember 3-4 years back, you used to have the IVR calls, right? Eventually now also you have a lot of IVR calls, but that has significantly reduced. Apart from any traditional banks who are basically using IVR, but significantly it has got reduced. Now what happened in this IVR? You need to, it's very boring, it's not an engaging. Okay, you need to every time go ahead and select those numbers. Okay, many people, they don't know how to interact with IVR. Okay, and because of that, they were not able to basically understand that what is the content of that IVR. Okay, or it never looks like to be a very professionalism, right? So few years back, okay, we started developing this chatbot. Now, chatbots, many people will think it's an if-else program. No, it's not an if-else program. Chatbots tries to understand what context you are basically choosing, okay, in which domain you are speaking, and what are the different topics, subdomains you have in that conversation, and then what is the next. When you go to the next, it means how do you respond to that chatbot. Okay, so this is what we are basically expecting. So now let us see a quick architecture of chatbot. Okay, so see, let's say we want to build a food delivery app, related chatbot. Okay, so food delivery chatbot, let's say. Okay, so what we need it for food delivery, what are the different contexts that we have? So first is, what is the item or the food, choosing a food item, right? So let me write down those and then we will convert into an algorithm. Choose a food item. And then you eventually go and proceed with ordering the food. Okay, so I will write it as order. And then after ordering, you proceed with tracking that whether my order is getting delivered or not. And third is, let's say you want to cancel. Generally, you don't have the cancellation option for food delivery because once it is prepared, you cannot cancel it out. Okay, so cancellation is really not always available, but typically you can also go ahead and cancel out at an initial stage. Okay, let's say once the food is not being accepted by the restaurant, eventually you can cancel out, right? So order, track, cancellation. Okay, and again the fourth one could be, let's say, reorder. Okay, the fifth one could be, let's say, feedback. Okay, feedback of your entire delivery. So these are the few you can say important points, okay, or important domains on which your conversation will rely. Okay, so whenever you build a chatbot, what sort of conversation you will have with that chatbot. So one is choosing what type of food you want. Okay, then put an order, try to track whether my order is reaching nearby to me or not, by when my order will reach, why it is taking so much time. All those kind of conversation will come under track. And then come cancellation. You want to cancel out the order, or you want to, let's say, drop that order. Then is reorder. Okay, so let's say you like that dish very much and you want to reorder, or you want to reorder immediately, or you want to reorder in future, whatever the time frame is, that will vary from customer to customer. But reorder is one of the interesting topic. Okay, more reorder means typically you can think that the customer is very satisfied with that particular restaurant, right? And then comes feedback. Okay, how well this entire order delivery experience is all about. Okay, so this helps. These four are the five topics that your conversational platform will rely upon. Okay. Now what will happen in these, this is the chatbot I'm explaining before transformer, before ChatGPT. Next to ChatGPT, what will happen, I will tell you later. Okay, so now based upon this, we will actually create a corpus of data based upon these individual topics. We will create corpus of data. What is corpus? Corpus is nothing but bunch of examples. Let's say when you go to a school, and when the kids go to a school, you get to learn like A for apple, A for aeroplane. Okay, like lot of example related to an alphabet, right? Similarly, B for ball. Okay, B for bull. So a lot of example we try to give to the kid to make them understand that how A looks like, or what are the words A is associated with. They really don't understand how apple looks like or how aeroplane looks like. Okay, they don't have a lot of picture in their mind, right? But how they learn is the way, the semanticness, the communication. Okay, with that they understand, okay, there is some sort of similarity. Okay, when they hear A for apple, A for aeroplane, okay, the initial words spells to be very similar. So that is how they start lining up the words, and they eventually learn, okay, how to pronounce each of these words. Okay, each of these alphabets. Okay, so something very similar over here. Okay, how an order statement looks like. Okay, I want to order pizza, I want to order biryani. Okay, can you get some biryani for me? Can you get one pack of chicken pizza for me? So a lot of such examples we need to set it out. Okay, so that our machine learning or the AI module can understand. Okay, so what we are trying to order. Okay, first of all, what we are trying to order. Okay, and how an order statement looks like. Okay, what is an example. Okay, so it's very similar like the human learn a new language. Okay, there are some words, some set of words that we heavily rely on to understand that what's that statement means to me, right? So it's very similar. So you need to give a lot of such corpus from every single you can say topics that we are discussing. Okay, reorder, feedback. Okay, cancellation, I want to cancel my order, my current order. Okay, in terms of feedback, the food quality was very poor but the delivery was very good. Okay, so you can set up a lot of examples. Okay, and these examples will actually help the backend AI machine to understand that what are the topics and what are their corresponding sentences. Okay, what are the topics and what are the corresponding sentences. So these area, okay, this part will be known as intent. Okay, so every conversation will have some intent. Whether you want to order, your intent is order. Whether your intent is tracking a food, whether your intent is canceling the order, whether your intent is to deliver some feedback. So whatever is your intent, so that will be predicted once we learn this from those sentences. Okay, we will basically train the model, and the model will learn that this is the intent for this set of corpus. Okay, for one corpus order, there are 5 sentences, and each of these sentences have some sort of semanticness between their words or their the entire sentence formation. Okay, so that is what the machine learning, the deep learning model learns, okay, with the help of neural networks. What is neural network? It's again a learning algorithm, okay, very similar to how human being learns. And we are basically using neural networks to learn this relationship between intent and the set of words. Okay, so that will typically help me. And there is no fast forward hand-picked rules. Okay, don't think that there is an if else condition. If order word is present, then it means it's an order. No, we never do like that. Okay, because with that we can only create some limited context. We cannot create unlimited context. So what we try to build it out is we try to understand that what is the relation between intent, these topics, versus their corresponding set of sentences. The next step is, you can ask me that, then how do we particularly capture some set of personal information from the data? So for an example, let's take some example. Okay, so let's say I want my pizza to get delivered by 3 p.m. to 3:20 p.m. Okay, I want my pizza to get delivered by 3 p.m. to 3:20 p.m. Let's say this is the statement. Okay, now what are the important set of information? Okay, this is of which intent? Can anybody predict which intent it belongs to?
Is a type of order delivery.
Okay, what about others?
Order.
Which intent out of these 3? Out of these 4, 5, 1, 2, 3, 4, 5, 6. Out of 6 intent, which intent?
Track. It's track. Track.
Correct. So it's a track.
Track.
Okay. So it belongs to the intent called track. So my model can now understand, because I have trained my model with this set of sentences. Now my model can understand, okay, this sentence is from track. But what is more important? What is the next level of importance that we need to capture? That is this time, right? This time is very important, 3 p.m. to 3:20 p.m. That has to be captured.
Correct.
And what has to be captured? My pizza, what food item that we are basically passing on. So in order to capture these, you need to frame some of these context in your mind. Okay. So while you deal with entire business on this food delivery business, what all type of entities you are dealing with? So one entity is food item. Okay. So far we were discussing only about intent. Now we will discuss about entity. Food item is an entity. It can be pizza, it can be biryani, it can be kebabs, it can be whatever, it can be any dessert, it can be any drink. Okay, eventually it can be a water. So food item is my first intent. The second intent could be name. Okay, any sort of name if the user is mentioning. Okay, so we need to determine that. We also need to determine date and time. Okay, if user is mentioning any date or time, so we need to determine these date time formats. So 3 p.m. comes under this time entity. Okay, 3:20 p.m. comes under this time entity. So we need to determine those things. And you cannot, typically those who know Python, you cannot keep on applying regex. How many regex you will apply? Okay, it is not possible. Okay, you cannot apply regex. So you need to build your model and you need to train. We call this as entities. So you need to first frame in your mind that how many such entities can be there. So food item is one entity, name is one entity, date is one entity, time is one entity. Okay, and then apart from that, we have address could be one entity. Okay.
In between, duration is the one entity.
Yeah, duration can be one entity. Okay, and that I will put it within this date time only, okay, like date, exclusive date, time, week, day, okay, duration, all those time driven information. Let's put on this. Means don't make your entity too big list of entity. Then what will happen? Your model need a lot of examples to learn.
What
Like,
if we write today?
yeah, so that also will be coming under this date time. Okay, today, tomorrow, yesterday, okay, all of those things should come under single entity, so that you give as much as an example with that particular set of tokens, rather than breaking your entity into smaller set of fragments. If you break that, then what will happen? You need to pass a lot of information over there. You need to pass a lot of, you can say, examples. So sometimes you will not have a sufficient quality of data, right? So for that reason, I always suggest that put your entities limited. Don't put a lot of entities. So food item, name, date, time, address, okay. And what else? Quantity. Quantity could be another entity, right? That I need two quantity. You want to increase the quantity, you want to decrease the quantity, whatever it is. So quantity could be one of the entity. So like that, these informations will be present in each of these intents. Okay. So entity are what? Entity are those the informations that will be a part of your intent. Okay. Entity is those informations that will be a part of this intent. So similarly, for each and every intent, okay, you will get some of the other information. Sometimes your entity may not be there. Okay. Just simple statement. It could be a very simple. I want to know my current status of delivery, where there is no entity available. Okay. No food item, no name, no date, no address, no quantity. So it can be a single intent as well, or it can have any set of entity attached to it. So you need to also express in your data that this is my entity while you train. Okay. This is belonging to an entity. So let me show you how do you express that. So we call this as annotation. Okay. I need to annotate it. We call this as annotation. So how do we annotate? So let's say I want, what was the statement I want? Okay, I want my pizza to get delivered between, I want my pizza to get delivered between 3 p.m. to 3:20. Okay, so now what we will do is, this is an entity. So this particular word is defined as food. This particular word is defined as date, time. I'm writing together. You can also segregate. That is up to your wish and choice. Because in food delivery, you will typically not have a lot of time elements. Mostly it will be, sorry, not of date elements. Always it will be time element, because it's an instant. Within an hour, it's happening. So I want my pizza to get delivered between 3 p.m. to 3:20 p.m. So it's a date time. So I am basically, what I'm doing is, every sentence I am taking and I am annotating the information that this is food, this is date time. Okay. So now, and at the same time, I'm also saying that this entire module is an intent of track. So this annotation, this is what we annotate for each and every sentences. We take the data and we annotate it, and then two way we annotate. First, we annotate all the intent, then we annotate all the entities, and then finally we train our language model, or you can say a neural network in a very layman term for those who are very beginner. So you train the language model or neural network, which basically tries to learn that what type of sentence are there between in this track intent. And it also tries to learn about these entities, what type of word defines this entity. Okay, this is date time. Okay, this is a food item. So all these becomes the part of your intent and entities. Now, once it is learned, now you can go ahead, you can pass each of these statements and you can go ahead and predict it. Okay, once it predicts, so it will predict that, okay, this sentence belongs to the intent called track, and these are the entities. And based upon these entities, you basically go ahead and choose the action. Okay, what response it has to be given, that we call it as action. Okay, so if it has to give an action with respect to, let's say, your order will be delivered in the mentioned time period, okay, 3 p.m. to 3:20 p.m. So this action is somehow previous to ChatGPT. This sort of actions were very much constrained, okay, and not previous to ChatGPT, even now as well. We try to keep these action in controls of business hand. Okay, so what I'm trying to express is, let's say a restaurant is overburdened with lot of deliveries. The restaurant cannot deliver by 3 to 3:20 p.m. and your bot said that, okay, yeah, I will deliver by 3 to 3:20 p.m. Then it's a contradiction, right? Your restaurant cannot deliver, as well as your bot was trained on the set of examples and it took and said, so it's a contradiction happening, right? So in that case, some of the actions we will basically, previous to ChatGPT, all the actions were manually given. Okay, means the logic where we used to build the logic where we keep all those actions. Okay, so if this is the intent, if this is the intent, and if the content is food and if it is date time, then it means that we will say that, okay, our order will be delivered within stipulated date and time. And during peak hours, we will say we will try to deliver your order in your stipulated time period. Okay, while if the order comes from a non-peak hours, okay, let's say in the afternoon, or let's say in the late night, then the action will be different. Then the action would be, okay, we will basically deliver with the stipulated time period. Okay, so you can build your business logic by taking some of the scenarios as a part of your action. Okay, and you need to build your action, because otherwise your model, your language model will be predict what the end user is trying to convey, but you need to have an appropriate action to give a response to that particular end users. Okay, so that response are mostly stored in the database earlier. Okay, now what was the limitation of this? The limitation is, it is very you can say, you need to spend a lot of time in annotating this. First limitation is this. Okay, annotating each and every word is very you can say tedious task. You cannot do the annotation so easily. Okay, you need to have some domain knowledge before you annotate. Now this is very simple, this is very easy. Okay, there are a lot of conversational platform where you need to have a domain expert to annotate this information. Okay, something, let's say some conversation going on a banking terms or a finance terms. So in that case, you need to have that domain knowledge, and then after you can basically go ahead and use it. Okay, so one limitation is you need a lot of time to annotate. To generate this sort of good quality data, you need to annotate very precisely. So you need to spend a lot of time in annotation, which eventually can take from a few days to a month. Okay. The second disadvantage is our model is very much specific to this food delivery domain, because we are training with these intents: order, track, cancel, reorder, feedback. We are just training within this few set of intents. So our model is very much limited with this set of intents. But there is a, you can say, a good advantage that most of the people who communicates with food delivery app will not speak about, apart from anything from than that particular order. You will not speak about World Cup, right? You'll only speak about this particular order, where is my order, by when it will reach. Okay, so we really don't bother much about it. But if I try to build um, let's say a chatbot which can answer all my queries, so that is not possible technically. You need to focus on that specific domain, and then you can build chatbot. Okay, the same that I showed you an example, gave you an example of food delivery app chatbot. It's the same thing. You can do it for, let's say, your Uber or Ola, or your locomotive application as well, where you can try to figure out where is the nearest car. Okay, by what time it will reach my destination, what is an expected time. So those all information already you get it, but yeah, you can also communicate and get it back. Similarly, you can also build your chatbot around finance, around retail space. But all of these are very specific to the use case. You cannot build a very generalized chatbot. So that was one of the biggest disadvantage. Okay, if I want to build a generalized, it is not really possible. And that's why you see Apple Siri, eventually Amazon Alexa, okay, they were very limited to some questions. It can only switch on the fan and all, but it really didn't give a very good impact in order to answer very complex question or very interesting questions, because it doesn't have that capability, because this intent and entity will not allow to expand. It's a problem. Okay, means these many intent, and you cannot keep on adding intent. So scalability, the third problem was scalability. So the first problem is lot of overhead work needed to be done for annotation. Second problem was you cannot build a generalized conversational platform. The third problem is you cannot basically expand, you cannot basically scale your chatbot. Okay, if you want to scale your chatbot, a lot of cost is involved in it. Okay, again, you need to annotate, you need to figure out a new intent, you need to write down the actions. So there are a lot of challenges which were not making the natural language processing, this particular conversational AI platform, very successful. A lot of organizations were investing huge amount of money, but they were not able to get a very successful model until this transformer came into the picture. So by this time, if you have any question, I will be happy to answer. Anybody, any questions, any doubts?
So Rishabh, this is Rupak. This is
Yeah.
great information. But during this time, can you also tell us what is the current ecosystem of chatbots look like? Because a lot of things have advanced in this area, and a lot of options are out there when we go out to look for it. I'm talking not from the development standpoint, but from a using standpoint. So if I have a company, or we are trying to tell people what are the different chatbot solutions they can implement, then how do you go about making that decision?
Sure. I will give that. I will give that picture. No worries.
Hey, Raj here.
Yeah. Hi.
So, as you said, right? So there you're using a transformer. Are they using any vectorization techniques? Like, I'm a bit confused between these two, like vectorization of these words and the the transformers. It
Okay.
would be helpful for the if you give the information.
Okay. Sure. I will explain it. So first of all, I will give a brief about transformer. Okay, and then I will jump into how these things getting implemented. Okay, so transformers, like, this model, whatever we have seen, okay, so they are basically not using transformer, okay, so they were pretty much using your attention based LSTM models, okay. So attention based LSTMs are basically using the sequence vectors to learn about its net sets of sequence. So for an example, I want pizza to get delivered by 3 p.m. to 3:20. So I want these two sequence will actually impact my, I want my, these three sequence will actually impact pizza. Okay. So this particular sequence model were very much in use so far while before the transformer came into the picture. Now, the problem of the sequence models are, okay, that if it is a very long sentence, let's say I take a very long sentence, okay, I take a paragraph, let's say I take a huge paragraph, 5 sentence. Now the word over here, the word over here, and the word over here, they were not able to really very relate, because in between there are so many tokens that were available. So eventually what was happening is, in a very long sentence, the problem with relating its word and its impact to its last word is losing out. Okay, so because of that, attention came into the picture. Okay, so that the attention mechanism were helping that some of the words which are very important, let's take those set of words, okay, and make the model remember about a very long context. And there also came a new model called bidirectional LSTM. So far our words were only relating, so I and want, it was always feed forward, okay, then I want both together came in picture, and then focusing on the predictability of mine, then I want my, all these three came, and basically predicting for pizza, okay, it is always a feed forward, okay, but bidirectional came in picture, and then it started feed forward as well as backward as well. Okay, so how does it happen? Let me explain a bit. So so I and want is there, want and I is also there, okay, and then I want my and want, so both way it is traversing. Okay, when it is traversing both way, the advantage that it get is these inputs gets into a attention vector. Okay, for those who don't know, you don't need to worry. Okay, this is all that we cover in our course, but just to give you a gist of it, everything cannot be touched in depth, but I'll try to make it much easier. So attention vector gives an importance. Okay, so want is an important vector here out of these two. Okay, I and my, because it gets both the information, feed forward, I want my, as well as my to want. Okay, and eventually from pizza also, like it keeps on going, right? My to pizza, pizza to my. Okay, so it basically learns between the tokens, and as it basically learns between the tokens, it needs to understand that which set of tokens we need to give more importance, and that is where this attention vector comes in place, which basically tells, okay, want is an important token, pizza is an important token, 3 is an important token, 320 is an important token. Over a period of time, with set of example, not with one sentence, it will understand which is important. Okay, it needs to have a multiple examples to understand that this is the pattern, this is the semanticness between the words. Now this is how basically so far the model used to work. Okay, now what was the disadvantage over here? Eventually, for a very long set of sentence, we were trying to solve the problem with the help of attention, but in very long context, we are somehow losing this context and as well as word importance. Okay, so want and 3 p.m. in this sentence has a very direct impact, means the vectors won't change so much, versus if I have, let's say, 10 sentence and 3 p.m. is at the 9th sentence and 1 is at the first sentence. So 1 and 3 p.m. will have a very, very least impact. So you doesn't basically, eventually you will not able to relate much. So that was the challenge so far. And after this, what we and apart from that, the major problems were this annotation is also a very biggest problem. So we were not able to annotate. So that was the biggest problem, and a lot of manipulation needed to make this data ready. Okay, so now the next thing is coming to transformer. Okay, so transformer is a bit different. It doesn't work sequentially, it works parallelly. Okay, so it takes every single sentence. Let's say I want pizza. Okay, I'm taking a shot. I want pizza. So each of these have a vector. Each of these have a positional vectors as well, because their position matters to generate the sequence and the linguistic and semanticness of the tokens. So positional vector is one of the key important aspect. And then comes their own vector, the word vectors as well, their own word values as well. Okay, so positional vector, word vector, they both come in picture. And then it gets into a multi-head attention. Okay, so there are two parts to a transformer. One is the encoder part, another is the decoder part. So there is two parts, the encoder part, and then you have a decoder part. Now, in this example, in this explanation, you will not really get a complete picture of it because it is very in-depth. And once you understand a lot of things, then transformer comes in place. Okay, but just to make you in a very layman terms, okay, I'm just going with a very layman terms to make you understand. So the encoder, what it does is it takes all your input informations. The decoder takes all your output informations. Okay, encoder takes all the input informations, means the one which you are training. Decoder takes the ones which you want to predict. Okay, and both of them, encoder will first get the positional vector as well as positional vector means their position. Okay, like I will be always before want. Okay, if I say want I pizza, does it make any sense? No, it doesn't make any sense, right? So position matters a lot. Okay, in language, position matters a lot. So that's why this positions is mentioned by this position vector, and each of these basically will have an embeddings, word embeddings. Now what happens once it gets into the encoder? What does the encoder do? It basically tries to mask few of the values, few of the words, and try to predict that particular set of word. So let's say I want pizza, want is masked, means it's a fill in the blanks. Let's say I dash pizza. Okay, so it tries to predict want. Again, in the next iteration, pizza will be removed and you need to predict pizza. I want pizza. So with the iteration, with couple of iterations, not couple means 100+ iterations will keep on happening, so that you basically try to learn how to frame a sentence. Okay, in a very big sentence, you keep on obsoleting some of the words and you basically try to predict that word. In this due course, you try to understand, okay, so this is the word that comes after I, want is the word that comes after I. Okay, then comes pizza. Okay, it never be like I pizza want. Okay, it cannot happen like that. Okay, so in this way, encoders basically tries to learn, okay, the semanticness, and the decoder is basically helping. Okay, there is another model called as decoder. Okay, this decoder is basically trying to generate this entire text. Okay, encoder is helping to mask the set of context and then try to predict. Decoder, on the other side, you have the output, right? The one that you want to generate. and input is basically the one that you pass on. Okay, and both basically work together. They are basically connected, appending together to the decoder, and decoder generates the final result. Okay, it generates the final result. So now the decoder functionality is somehow more generative in nature. Encoder is more with learning the semanticness. Now what decoder does is the one that you predict, okay, the one that we absolute, okay, we obsolete it, okay, like this pizza, we obsolete it, right? We want to predict pizza. So the decoder is basically trying to sorry, I didn't get your question. Any question, Pranav? Okay, I think, okay. So the decoder is trying to generate that context. Encoder is trying to learn the semanticness. Decoder is trying to generate that context, that what is that particular set of word that will basically be placed over here. So like that, what we started doing is we started punching a lot of information, okay, and we tried to generate some results out of it. So in this chatbot, what we are doing, we are trying to detect intent and entity, right? And we want to predict what intent entity. Now, what we are doing over here is in this transformer, we will pass all our information, all the intent, all the entity together without any annotation. We are not going to do any annotation. Okay, just raw text we will pass, all the sentence we will pass. And what should be the output? So if I say hi, if I say hi to the chatbot, my chatbot should say, hey, how are you? So this will be my input, this will be my output. Okay, so these two information, question answering, okay, like I ask a question and whatever the answer you want to generate, just pass it in your output. So input and output, you need to make it ready and you train your transformer and eventually it will give you your results as an output. So that is how transformer works, but it is not so simple. I just try to make it in a more English manner. I didn't show any mathematical execution and all. Okay, we don't have much bandwidth, but yeah, I will show you some live example now. So transformer, what is the advantage? You don't have any limitation on annotation. Don't need to annotate anything. Second is you just need to punch a lot of information. The model will automatically come to know that what is the word and how do the particular semanticness got generated. The model will automatically come to know that. How? With the help of this masking technique. Okay, with the help of this masking technique. And then after it also tries to generate based upon the output that we have. Okay, and finally we get our result. Okay, so this is the process in a very like I'm going into 100-feet view and explaining you so that you understand the concept in a better way. Now, one of the misconceptions, people thinks that it is connected to a Google or it is connected to internet. ChatGPT is not connected to anything. Okay, none of these data are connected to anything. So you have the data, we take that data, we pass on that data in these two forms, input, output. In the input, you should have subsequent amount of examples. In the output, you should have the responses that you want to deliver. Okay. And then you teach your model about the entire context. Now, the question is, then how does this ChatGPT frame in a very simple manner? Whatever question we ask, it basically answer in a so good way. Okay. The answer is very simple. The quality of data. Okay, you need to train with a good quality of data. If you train with a poor quality of data, model will never learn. Like if I always tell you A is equal to apple, if I don't tell you A is equal to can be airplane, okay, A equal to something else as well, okay, you will not able to understand. You cannot think around that dimension as well. Okay, so quality of data matters a lot. ChatGPT was developed with a very good quality of data pre-processing, and all of those things are very efficient in this particular journey. So that's why these models are very, very efficient. Okay, the model is very efficient and huge volume of data that it has basically dealt with. A lot of examples. You need to showcase a lot of examples, then only you will learn, right? If I ask you to learn French today, you cannot just frame the sentence by learning one word. Can you frame a sentence? No. You need to know how many different examples of that word can be used, and then only you can frame the sentence. So it is very similar. So lot of data required from the input side, lot of data required from the output side. What are the different type of answers that you can get? Okay. Third point is, many people say that it doesn't gives you a correct result. See, one thing you have to understand, this is a language model, and information will have some limitation. Human beings are one of the most good processor of information. Okay, you and me can process a lot of information, while we still don't know many things. Okay, even I don't know many things, and eventually everybody doesn't know many of the things, right? So we only process the information that we are interested with. Okay, so now let's say if I start asking a very narrowed question, okay, which maybe the model is not trained with, in that case it will not able to answer very efficiently. Okay, it is also not a good way to think that whatever I train the model will be able to answer. That's not correct. Then it becomes a very overfitted model. Okay, so we need to train our model in a way with a lot of example, make it more generalized, get into a lot of similar set of results and questions, and then finally you get an answer. But the questions that you are asking should be like, if I say that what is the meaning of life, ChatGPT won't be able to answer very efficiently. Okay, because those kind of questions may not be, sarcastic questions may not be very relevant. Okay, so you need to understand those differences. Okay, and then you can shoot a question. Then you can shoot a relevant question and get a relevant answer for it. So that's how basically we focus. Yeah, any other question before we start the hands-on?
Nothing easy move.
Great. Okay, just give me a minute. Cool. So let me now share my screen.